Okay, so having seen how to simulate something kind of simple like wind, we can now take a look at some more complex physics. Again, I'm going to say this about all these examples. We can go so far into the kind of like mathematics of modeling these things. This gets really, really complicated. So we're not going to go super far into modeling physics here. But gravity, I think, is a really good one for us to talk about and see. And it's actually not super, super hard. So here I have this bouncing ball, and we can change how fast it falls and how bouncy the material is with this. And then in the video after this, we're going to see how to convert this from using just numbers to represent like X and Y to using P vectors, which will give us, open us up actually to a lot more complex kinds of stuff. So I'm going to go ahead and make a new sketch. And just like in the wind example, I'm going to use surface.setLocation at 0, 0, just to draw my sketch window over here. And actually, let's make this a little bigger. What would be kind of fun actually is instead of just being square, we could even make this a little bigger. Let's try 1200 and see. That looks, no, it's getting cut off a little bit. And for some reason my dock is hanging out. Let's just, I don't know why it does that periodically. Okay, so that's good. We got a nice like tall thing to drop down from. So we are going to recreate gravity in this sketch and have this little ball drop. And so we definitely are going to need an X and a Y position for that ball. And let's just start, oh, and a diameter. So I'm going to create a variable called diameter of 50 pixels. And just like before in the wind example, we want to test everything step by step and make sure it's working correctly. So I'm just going to draw the ball, and then we can add the movement to it. So we're going to start it at width divided by 2. For the X and Y, let's start it at the top, but we don't want to cut off, so maybe we'll make it at diameter divided by 2. That way it's kind of like hovering right at the top. And our draw, again, you could change the colors to be however you want. I'm going to make this ball white, no stroke, and then there'll be an ellipse at X and Y, and diameter by diameter. Now, one of the reasons that I'm not giving X and Y an initial value up here when they're created, the first reason is that I want X to be able to be relative to the width of the screen, and that may change. I don't have access to width until the size command has been run. And the other reason is that we want to be able to reset this. So I don't want to have to run the sketch over, stop it, and run it again every time I watch this thing bounce. So by putting them in here, then I can say void key pressed. This runs anytime a key is pressed. I can just call setup. And so now anytime a key is pressed, it's going to pop up here and reset everything in the settings basically. So now that my position will get reset. So let's run this. There we go. So my ball is sort of hovering up here. That looks kind of cool. And now we want it to be able to move. And to do this, we need to be able to know the ball's speed and have it move down. So I'm going to say float speed equals. Now we're going to be adding to this as we go. So speed right now is going to be consistent, and we'll see it just sort of like fall straight down. So let's say every frame I want it to change by 2 pixels. And then we could say y plus equals speed. And now when I run this, we'll see it go straight down at a consistent rate, which is not supernatural, or I mean, it's not very natural. It is supernatural, but it doesn't feel natural to us because there's no acceleration or anything going on here. And then obviously it falls off past the bottom of the screen, and that's where having this key press part is really nice, because I can just hit the space bar or something and have it sort of reset that motion, and I can watch it. So just adding that speed doesn't seem quite right. And so instead what I'm going to do is I'm going to define a value for gravity. And we're going to use a float. Again, float for everything. This is going to make our ability to tune kind of these parameters work a lot better. We do need a speed though. So speed is going to start at 0. The ball is going to be hovering and not moving. And then slowly gravity starts pulling on it. And we'll have more and more pull as it goes down. And it'll get faster and faster. So I'm still going to have a speed variable, but we're going to set that equal to 0. And actually, you know what? It probably makes sense to do this in our setup as well. So our speed is 0. Then we don't want to change y directly, because then what we want to do is change the speed based on gravity and then set update y based on the speed, if that makes sense. So we're going to say speed plus equals gravity. So our speed's going to get higher and higher, and then y is going to plus equal speed. You can see here now, it's a little hard to see because it happens really quick, but the ball starts out kind of hovering and then feels like it drops. So kind of like if you were holding it and then letting it go. And the reason is, so our speed again gets updated every frame. So the speed starts out at 0. Maybe we can print line speed here so we can see that. If I pause that, maybe we can scroll back and see. So it starts out at 0. And then, well, actually, it starts out at 0, but we don't see the printing yet. And then it goes 0.5, 1, 1.52, so et cetera, et cetera. So every frame it gets faster by 0.5. And it's, then it just keeps going. And then we update our y position using that speed. So when speed is 1, the y, that frame moves down by 1, but when speed is 5, it moves down by 5 pixels, and it looks like it's moving quicker and quicker. Which, I mean, again, this is like really simple. It's not intuitive necessarily to like think about how to do this, but it is really simple, and the math is not that complicated. And we can see if we change the gravity to be much smaller, for example, our ball falls much slower. If we were to make this higher, it falls much faster. So I'm going to keep that at 0.5. Again, these are variables you can start playing with and seeing how it changes the result. So then the next thing I want to do is have this ball not go past the bottom of the screen, because obviously that's also not very realistic. So I need to know, the first thing I need to know is when it's hit the bottom. And in order to do that, I need to compare the y position to the height. So I'm going to say if y plus the diameter divided by 2, because I want the bottom of the ball to hit, not the center of the ball. Y is the middle. I want to know if that bottom, y plus the diameter divided by 2 is greater than height. For now, let's just have it bounce straight back up, and then we'll see how we can make it bounce in a more natural way. I can say speed times equals -1. So this is going to reverse it. Speed is going to go in the opposite direction. Let's just start running that. Pretty cool. And we will see, because gravity is always playing a role here, it is slowing down, but it's not doing it in a very natural way. Like, this is a incredibly bouncy material. So instead of, and then it gets caught here, and we'll fix that in a second as well. Because we're using this -1, it's just sort of going back at the same speed that it hit. But we know that when an object hits the ground, it doesn't convert all of that energy into bouncing back up. Some of it gets turned into sound, some of it gets turned into heat, and all that kind of stuff. So we can make one more variable here called Bounciness. And we can set that equal to a variety of things. Let's try 0.8 here. And so this is that number that we're using here. And instead of -1, I can say negative bounciness. And now when this hits, well, it's still getting stuck. So let's fix that as well. Now, the reason it's getting stuck is that as the ball is falling, when it hits the bottom, let's try to see if you can see on the screen there, as the ball comes down and it hits the bottom, it may be that the ball moves from here to here. So like partway, maybe this is easier to see, partway below the screen, and then it's trying to bounce back up, but it's not going high enough to escape, and it's sort of like getting trapped inside this thing. So what I think makes the most sense here would just be to say, if it's hit the bottom, if it's past the bottom of the screen, y equals height minus dia divided by 2. So basically resetting its position so it's right on the bottom of the screen. So now when we run this, we can see that the amount it's bouncing decreases by a lot, much more naturally, and the ball sort of just like then eventually sits there. And we can try changing this bounciness number and see how it looks to be like a different material. So here now that looks much more like some kind of like really hard rubber. We might see something that, you know, sort of like lands and thuds, like, I don't know, a steel ball on ice or something. We can make the bounciness much higher. So this is like a, I don't know, super ball or something like that. And you can see how changing these numbers are really going to change the sort of like feel of this object falling and bouncing. Again, so you can change gravity, you could change bounciness in, I think, really actually kind of cool ways of doing this. We could also certainly make this work better, again, if we were to go with an object-oriented approach where we had a ball class, we were defining gravity globally and the bounciness locally, and we could have a whole bunch of balls dropping with different levels of bounciness. Could be really, really cool. For now, we're going to leave that off. If you want to try that, I think that would be a really awesome challenge to take on. And in the next video, we're going to see how to convert this example from using x, y values into using p-vectors, which will give us more kind of control over the physics.